As we continue with our 2.3 notes, we're going to keep practicing solving quadratics with more than one variable occurrence. Again, if we look at this next example, we see x show up in two different places, meaning that we're going to try to factor if we can. If not, we'll use quadratic formula. But the only way we can use either of those strategies, factoring or quadratic formula, is if this equation is set equal to 0, which it is not. So just like we did in the previous example, we're going to start by subtracting 1 on both sides to get 3x squared minus 2x minus 1 equals 0. I personally prefer factoring over the quadratic formula, so I'm going to start to see if I can factor this. See if I find two numbers that multiply to negative 3x squared and add to negative 2x. Those two numbers would be negative 3x and positive 1x. This time I'll show my example using the factor by grouping methods because I used the think about it method up above. So with the factor by grouping method, I really just rewrite this quadratic, but instead of my middle term, I put my two new numbers. So 3x squared minus 3x plus 1x minus 1 equals 0. I'm going to group them, first two terms and second two terms, and look for GCFs. With this first group, my GCF is 3x, and I'm left with x minus 1. And with this second group, my GCF is 1, and again, I'm left with x minus 1. Then in factored form, I have x minus 1 times 3x plus 1 equals 0. From there, since I have two different factors equal to 0, I set both factors equal to 0 individually and solve. When we do that, for this first one, we get x equals 1. And for this second one, if we subtract 1 first and then divide by 3, we get x equals negative 1/3. For the next example, we notice that this x occurs 2 times, so we're going to either try to factor and use the zero product property or use quadratic formula. What a lot of students are tempted to do on this problem is they notice that it's already in factored form, and so they would say something like, okay, x plus 3 equals 7 and x plus 2 equals 7. However, when we set factors equal to something like we did in our previous example, it has to be equal to 0. It's called the zero product property for a reason. So, just like we did in our previous example, we have to start by subtracting the 7 on both sides so that we do get 0 on one side. When we do that now, we have our x plus 3 times x plus 2, and then a minus 7 on the outside that we cannot combine with any like terms yet. When I do this now, I notice that it's not really in factored form or standard form or vertex form, so I want to first distribute and get it into standard form and see if I can do anything else from there. When I distribute, I get x squared plus 2x plus 3x plus 6, and then I still have the minus 7 equals 0. I'll combine my like terms and get x squared plus 5x. 6 minus 7 is negative 1. Equals 0 again. Now this is in standard form, and again I'm going to try either factoring it or using quadratic formula. So I'm looking for two numbers that multiply to negative 1x squared and add to 5x. And unfortunately those two numbers aren't nice numbers, and we can't actually factor it. So we're going to move on to quadratic formula. X equals, if you look back at the previous page of your notes, you can help me fill it in. Opposite of b, so negative 5, plus or minus the square root of b squared, so 5 squared, minus 4 times a, which is 1, times c, which is negative 1, all over 2 times a, which is 1. If we go through and clean this up a little bit, we've got negative 5 plus or minus the square root of 5 squared is 25. Negative 4 times positive 1 is negative 4, times negative 1 is positive 4, all over 2. And then we just add what's underneath our radical. So negative 5 plus or minus the square root of 29, all over 2. We cannot take the square root of 29, nor can it be simplified, so that's our final perfect beautiful answer. And then for this last example, again, we see x show up in two different places. So let's try just to get the x or let's get our equation set equal to 0. So I'll subtract 2x squared from both sides. And then I'll get 4x squared minus 4 equals 0. Now at this point, we might notice that we only see x in one place of the equation now, which means if we wanted to, we could just go and get the x by itself and we don't have to factor or use quadratic formula. This equation is factorable though if you wanted to actually factor and solve it that way. But right now I'm just using inverse operations to get x by itself. And when I do that, I get x equals positive or negative 1. Moving on to the next example, we've got two functions, f of x equals x squared plus x plus 1, and g of x equals 2x squared minus x plus 1. And I want to find the values of x where f of x equals g of x. So I'm just going to set my two functions equal to each other. So I'll say x squared plus x plus 1 equals 2x squared minus x plus 1. In this equation, I notice that I have multiple variable occurrences with x. So just like I practiced in the section up above, I want to get everything on one side so that it is set equal to 0. This time, I'm going to move all of this stuff on the left over to the right side, just because that makes my x squared term still positive. Okay, so when I do that, now the left side becomes 0. 2x squared minus x squared is 1x squared. Negative x minus another x is negative 2x. And positive 1 minus 1 is 0. Here, I'm going to look to see if I can factor this, and since there are only two terms, I'm going to look for a greatest common factor first. With 1x squared and negative 2x, I can factor an x out, and I'm left with x minus 2. So then, just like we did in a couple of examples prior to this, we set each of our factors equal to 0. So x equals 0 and x minus 2 equals 0, which means my two solutions are x equals 2 and x equals 0.